Okay, so in warm up number 5, we're talking about if something is proportional or non-proportional. So the proportional definition, it's when quantities have the same relative size. In other words, it's a ratio. So you can see these examples here. 1 kilogram is 20 meters, 2 kilograms is 40. So it's doubled. So that's often something that happens. So that means that it's the same, it's proportional. So for this one, on the very first one, we can say to see if it's proportional, we can set up a fraction. And think about if we bought 1 pound of plums for $3.99 plus $2 for the basket, that would be $5.99 for the plums. Now, is that equal to if we had 2 pounds? Then this amount should just double. So we'll see though. $3.99 per pound. If you're buying 2 pounds, that's $3.99 plus $3.99, which is $7.98 plus the $2. So that would be $9.98. But if that were true, then it would reduce, or it would be the same fraction or the same decimal. So if you do 1 divided by 5.99, that's 0.1669. It should be the same if you did 2 divided by 9.98. Nope, that's 20 cents instead of the 16 cents. So this one is not proportional. Okay, so now when the babysitter charges $12 per hour. Well, when we think about that, if we have 1 hour, it's going to be $12. Is that equal to if we have 2 hours, that will be $24? Well, let's test in our calculator again. 1 divided by 12 is equal to 0.083. So 0.083. And now we have also 2 divided by 24. That's also 0.083. So yes, this one is proportional. Okay. Now this wants us to answer, oh, does the table represent a proportional relationship? So let's think about it. If it were proportional, then you can look between two relationships and see over here. I always like to put y over x, so 9 over 2. And then I'm going to use one without a 0 in it. I'm going to use this one. Is that equal to, remember, y is negative 9 over x. Oh, which is 8, not x. Okay, so let's check with our calculator and we can see 9 divided by 2, that's 4.5. And now let's see here, negative 9 divided by 8, that one is 0.56. So that one is not proportional. Okay. Now it's asking us, Justice believes this graph below represents proportional relationships just because it's linear. Do you agree? Why or why not? Hopefully you have your answer written. The answer would be no, it is not. And here's the explanation. For something to be proportional, it must pass through the origin and it has to have the same slope on both sides of the line. So, for instance, it will pass through the origin and it will have the same diagonal or the same